Okay, guys, I've put a system of equations up here on the board. This is a line, and this is a different line. And there will be one point that lies on both lines, and that's what we're looking for. The point that is on both lines is the pair of numbers that makes both equations true. In the next couple of lessons, we're going to learn a couple different procedures for solving a system, and I'm going to try to convince you to somehow use, or sometimes use one procedure and sometimes use the other procedure. The procedure that we're going to use in this lesson is called substitution. Now, coaches are very familiar with substitution. If you have a volleyball team and you want to take one player out and put another player in her spot, that's a substitute, okay? Hopefully the person that you replace her with is just as good a player or an equivalent player or even better player than the one that you took out. And that's kind of the idea that we're going to do here. When I look at this top equation, and this is really the key to this particular problem, it says that y is the same thing as 5x minus 11. So 5x minus 11 could be considered a substitute for y, because 5x minus 11 is the same thing as y. So what I could do is I could go to this equation, take out y, and put in y's substitute. So I'm going to take y's substitute, which is 5x minus 11, and put it in y's spot. That's the whole idea of substitution. So this is line 1, and this is line 2, and now line 2 is going to look different. Its equation is going to look different. 3 is going to stay 3, x is going to stay x, minus is going to stay minus, 4 is going to stay 4, but I'm not going to write down y, I'm going to write down y's substitute, which is 5x minus 11. And notice again, when I put two terms in for y, I have to put those two terms in parentheses, because up here it says 4 times y. I got to make sure that 4 gets multiplied times the entire substitute for y. Now the equal sign is still there, and the 10 is still there. Everything in this equation is the same. It's just we've lifted out y and put in y's substitute. And notice then when that happens, I now have an equation that only has one variable in it. This equation had two variables, this equation had two variables, but by doing that substitution process, you end up with an equation that only has one variable in it, and we've been doing that ever since Unit 1 in this course. Let's solve this equation for x, okay? So, Isaac, first step?
So we'd start by using the distributive property.
Good. So what would you get if you distribute this negative 4?
Negative 20x.
It's negative 4 times negative 11. How about plus 44, right? 4 times 11. And the right-hand side is still 10. Rebecca, the next step?
Combine like terms.
So that's what, negative 17x? And Jackson, the next step?
Subtract 44 from both sides.
And 10 minus 44 would be negative 34. And Isaac, back to you, the last step.
So we would divide both sides.
That way, x is by itself, and over here, a negative divided by a negative, I've learned that x is 2, okay? Now, don't quit there, because remember, we're looking for a point, which means we're looking for an x and a y. All we know so far is that x is 2. But fortunately, we have a little formula up here that says if you know what x is, put into this formula and it'll tell you what y is. If x is 2, 5 times 2 is 10, and 10 minus 11 is negative 1. The point 2, negative 1 makes both of these equations true. Here, when x is 2, y turns out to be negative 1. And here, notice, 3 times 2 would be 6. Negative 4 times negative 1 would be positive 4, and 6 plus 4 is 10. That's a good way to check yourself. Make sure that whatever point you come up with, it makes both equations true. Now, I got to tell you that I made that question up ahead of time, and I made it so that it would turn out to be a nice pair of whole numbers, or at least integers. That's not always going to happen. And I want to point out that in my system of equations, the first equation told me what y's substitute was. In other words, it was solved for y. And that's not always going to be the case. So in my second example, I'm going to do the following. 4x minus 7y equals 3, and x equals 2y minus 4. Now, I just made that one up off the top of my head. I doubt if it'll come out to be nice whole numbers. But look at the difference in the system. This time, it's x's substitute that I have. So I only use the substitution method if one of my equations either says y equals or x equals. And in the next lesson, we'll learn what do you do if that's not the case. But if one of my equations says y equals or x equals, then I've got a substitute. This time, x's substitute, the thing that x is the same as, is 2y minus 4. So that's x's substitute, and that's what I'm going to put into the other equation. Once you find one of your variables substitute, you substitute into the other equation. So this is line 1 and this is line 2, and this time I'm going to line 1 and I'm going to substitute 2y minus 4 for the x. So here we go. 4 times, but I don't write down x. Instead, I write down its substitute in parentheses. Okay? Then minus 7y equals 3. That's just a rewrite of line 1 with x's substitute put in for x. And now, just like the previous example, we can solve this equation because it only has one variable. This time we're finding y instead of finding x, but the point is it only has one variable. So let me very quickly do this. I'll distribute the 4, so I've got 4 times 2y is 8y, and 4 times negative 4 is negative 16. I'll combine the like terms. 8y, I can't believe it, it's going to turn out to be a whole number. 8y minus 7y is 1y. And I'll add 16 to both sides. And this time I got that y is 19. So this time we found y first. But the point is you don't want to stop because you still have to find x. But that's what's nice about this substitution method. X is 2 times whatever y is minus 4. So since I know y is 19, I just take 2 times 19 and subtract 4. Okay? So 38 minus 4 is 34. I can't believe I ended up with whole numbers. But what this is telling me is if I take 4 times 34, that would be 136, and then subtract 7 times y, which is 133, I'll get 3. Okay? It makes both of these equations true. So that's when I use the substitution method, is when I have y equals something or x equals something. You know, if you don't have that, let me just do one more quick example. And this one's going to come out to be nice. Suppose I had x plus y equals 7 and x minus y equals 2. Okay? Neither one of those equations gives me a substitute. Neither one of them says y equals or x equals. But with just a little bit of work, I could make that happen. Like, for example, if I just took this equation and added y to both sides, wouldn't it say x equals 2 plus y, if I just add y to both sides of this one. So now I've got a substitute. I've got a substitute for x. So I go to the other equation, and I put that substitute in. I put 2 plus y in for x and leave everything else alone. Now in this particular example, the parentheses are not important because there's no number out in front to distribute. There was no number in front of the x. But y plus y is 2y, and if I subtract 2 from both sides, the right-hand side would be 7. So I didn't get a whole number. Y is 7/2. But here's my formula for x. All right? Did I do that correctly? Yes. 2 plus y should tell me x. When you look at your substitute, that will tell you x. So 4/2 plus 7/2, it looks like x is 11/2. Okay? We made a mistake somewhere. Where is it?
I don't see how we got 9.
I don't either. Very good. I knew right away we had made a mistake because what I did is I looked at these two numbers and I said, do they add up to 7? And no, they add up to 9. They add up to 18/2. Yeah, this should be a 7 over here. And so when I subtract 2 from both sides, this should be a 5, right? Better? So y is actually 5/2. And if y is 5/2, 4/2 plus 5/2, x is 9/2. Now they add up to 7. Okay? Thank you, Becca. So that's the substitution method. And if one of your equations says y equals or x equals, I would definitely use the substitution method.